Hello students to Calculus 1, and in this lecture we're going to talk about left limits and right limits. That's an interesting idea, relatively simple, but I copied here on the screen the graph from 2 lectures ago in which we calculated different limits. Let's quickly go through the procedure one more time just to see what's going on. So let's see. We want to find the limit at when x approaches 3. So we look at this point, and as I said before, we trace the values when we're approaching 3 from left. And when we approach 3 from left, we're going over the function this way. And we see that we're approaching value of 1. And if on the right side of 3, we can see that we approach 1 from the right side over here on the curve. So we concluded that the limit is equal to 1 and f of 3 was 1. Then when we move to x equals 5 and we're getting closer to 5 from left, we're moving along this piece of the curve and we're moving towards 5. But when we approach x equals 5 on the right side, moving like this, we're moving along curve over here, and so we approach 9. Okay, and for 7, we approach 7 from the left. If I approach 7 from the left, we're moving along this piece over here, so we're moving towards 6. When we approach 7 from the right, we're moving along this piece over here, so we also approach 6. And so the limit was 6, but for 5, the limit was undefined, so it didn't exist, or doesn't exist. The last thing is for 10. When we approach 10 from left, we're moving from over this piece of the curve towards 2. And when we're on the right side of 10, we're moving along this piece towards -3, so we concluded that the limit does not exist. In all of the things that I just was talking about, it was really important to move from the left and move from the right. And that's what captures the left limit and right limit. So let's try to define these things. So I'll leave a little bit of space here because I want to come back and fill in some details. So I'll start here. So I'd like to define limit from the left. So I'd like to define limit from the left. So again, I'm trying to capture idea that I'm only on the left side of the point, but not on the right side of the point. So that's why the name left. So we say limit of f of x when x approaches a, but I would like to say that it approaches from the left. So mathematicians put this minus sign on top and to the right of a, so it's like an exponent kind of a place. And it's equal to L, basically is the value that f of x approaches as x gets closer and closer to a from the left side. So basically, what do we mean by this? X can't be on the right side. That's what we mean by the limit from the left. So again, the main idea is to put this minus on a. That means you can only be on the left side. It doesn't change the sign of a. It could be positive number, it could be negative number. This minus on top means we just moving from the left side to A, but we cannot be on the right side of A. Okay, so we define the limit from the left. The next definition is the limit from the right. So in this definition, we want to define limit from the right. Or a lot of people say just right limit. So let's try to do that. We say limit of f of x is equal to L as x approaches A, but we want to be on the right side, so we're going to put a little plus. Again, it's on the top to the right of the letter. Is the value that f of x approaches as x gets closer and closer to A from the right side. And what do we mean from the right side? That means x can't be on the left side. Can't be on the left side of A. Or in the other words, we can say that x is greater than A. So maybe we should go back and add it also over here. Here we say, or x is strictly less than A. That's a good explanation. So what I'm going to do, I'm going back to my picture, and I would like to do this. Calculate the limit from the left and limit from the right for each of the points. So first one, we're going to do limit of f of x as x approaches 3 from the left. So let's go back to the picture. So if we approach 3 from the left, we're moving like this, so we don't really care about this right side. So we only have to be on the left side. And so we're still approaching 1. So we'll say that the limit of f of x is still equal to 1 when we approach 3 from the left. Then we would like to calculate the limit of f of x when x approaches 3 from the right. So we're going back to the picture. Now we can be on the right side of 3, so the limit is also 1, because when we approach 3 from the right, we're moving along this piece, we're moving towards 1. Conclusion, this is 1, and notice, this is 1, this is 1, and this is 1. So maybe it will play some role here. Okay, so we're moving over here, we say limit of f of x when x approaches 5 from the left. 5 from the left. So when we approach 5 from the left, we don't really worry about the right side, so we're moving towards 5, so we say the limit will be equal to 5. Again, from the graph, everything is really easy, just visual inspection, so it shouldn't be that bad. Now we do the limit when f of x, limit of f of x when x approaches 5 from the right. So if we want to approach 5 from the right, we have to be on the right side of 5. So we're going to be following this piece. So we're going towards 9. So we say 9 over here. And now let's look. This limit does not exist, right? The limit does not exist. And look, this number is different from this number. All right, maybe it will play an important role. So we're moving on, we do the 7. So limit of f of x as x approaches 7 from left. So we approach 7 from left. Let's look what's going to happen. When we approach 7 from left, we're moving along this curve over here. So we're going towards 6. So we say equal to 6. Then we do limit of f of x when x approaches 7 from right. So let's look what happens on the picture. We're on the right side of 7, so that means we follow this curve, and we're getting closer and closer to 6. So we'll also put 6. Let's notice something. This is 6, this is 6, and this is 6. All right, so last part is limit of f of x when x approaches 10 from left. So x approaches 10 from left. So when we approach 10 from left, we're moving towards 2, right? So we say 2. And the last limit that we're going to do is when x approaches 10 from right. So let's look. When we approach 10 from right, we're moving over here. So we're moving towards 3, actually negative 3. So we'll say minus 3. And look, this limit does not exist, and this number is different from this number. Let's look if we can see the pattern. And mathematics is the science of noticing patterns, right? So what is the pattern over here? Limit does not exist, and limit from the left is different from the limit from the right. Here the limit is 6, the limit from the left is 6, and the limit from the right is 6. Next one, does not exist, limit from the left is different from the limit from the right. Look, this is the same pattern, right? Does not exist, limit from the left is different than the limit from the right. Last part, limit is 1, 1, and 1, so all of them are the same. So this matches up with this pattern. All of them are the same, then the limit exists, and also they have the same values. The limit exists, and all of them have the same values. So main question that mathematician would ask, how do you write this rule? How do you write this rule? So the rule would be the theorem, right? So the theorem would be like this. So we would like to capture this idea. So we will say limit of f of x when x approaches a is equal to L, and I put this special symbol which actually means if and only if, right? Instead of writing this bunch of words, just put this symbol. So when does it happen? It happens when limit of f of x when x approaches a from left is equal to the limit of f of x when x approaches a from right is equal to L. And look, this rule works from left to right and from right to left. What does it mean? If this limit exists and it's equal to L, this tells us that the limit from the left will be the same as limit from the right. It will be equal to L. And also it works from right to left. If this part on the right is true, if limit from the left is equal to the limit from the right is equal to L, it forces the general limit to be equal to L. And this rule will be our last resort. When we'll try everything possible and nothing works, we will try this rule. And I'll explain a little bit more in details how we're going to do that. But again, this is if and only if rule. This is the strongest mathematical theorem you can have. All right, works from left to right and right to left. So the left side forces the right side to be true. And if the right side is true, it forces the left side to be true. Very, very strong theorem. We're going to use it in hard examples, but it's like our last resort. If everything else fails, we tried everything else, and nothing works, we'll try this idea in the future. All right. Probably a good place to stop. Probably good place to start this week. So I'll see you in the next week.